Numbers are used quite often in programming to keep scoring games, represent data in visualizations, store information in web applications, and so on. Python treats numbers in several different ways, depending on how they are being used. So let's first look at how Python manages integers, because they are simplest to work with. So you can add, subtract, multiply, and divide integers in Python. Let's do this following example. My value here, 2 plus 10 here, and let's print this value, my value. And here you can see here 2 plus 10 is equal to 12, or let's actually 9 subtract here 99 here, and as you can see here my negative 9 negative 90, and let's multiply it. For example, 5 multiply 5 by 10, oops, multiply 5 by 10, and here we have 50. And let's actually divide 5 by 10 and 0.5. So in a terminal session, you can also Python simply returns the result of the operation. And here Python uses two multiplication symbols to represent exponents like this. For example, 5 exponent 10 is equals to this here. For example, 3 exponent 3 equals 27. And 10 exponent 6 equals 1 here, 1, 2, 3, 1 million here. So Python supports the order of operations too, so you can use multiple operations in one expression. You can also use parentheses to modify the order of operations, so Python can evaluate your expression in the order you specify. For example, this. So my value here, 2 plus 3 and multiply by 4 or 5. And here you can see the first 5 multiplied by 5 here. So the spacing in these examples has no effect how Python evaluates the expression. It simply helps you more quickly spot operations that have priority when you are reading through the code. And we also have floats in Python. So Python calls any number with a decimal point. Python calls any number with a decimal point is a float. For example, this 1.478 is float. So this terminology is used in the. Let me actually firstly fix this here, because our marker menu should be here somewhere. Yes. So the term is used in most programming languages, and it refers to the fact that a decimal point can appear at any position in a number. So every programming language must be carefully designed to properly manage decimal point numbers, so numbers behave appropriately, no matter where the decimal point appears. For most part, you can use floats without worrying about how they behave. Simply enter the numbers you want to use, and Python will most likely do what you expect. For example, 0.2 plus 0.9, and here 1.1, and here, for example, 2 multiplication 0.2, and here, oops, sorry, yes, 0.4, and here we have the run it again, yes, 0.4, and here we have 2 multiplication by, for example, 99 here with some this, and here you can see we multiply this number with 2. So this happens in all languages, and let's actually, there's some bug here. Not bug, but you should see it. So here we have 3 multiplied by 0.1, and this here. So and this is a little concern, right? This happens in all languages here, in C++, in Java, and so on. So Python tries to find a way to represent the result as precisely as possible, which is sometimes difficult given how computers have to represent numbers internally. Just ignore the extra decimal places for now, and you will learn ways to deal with this extra spaces here. Just here, ignore this here for now. So when you divide any number, so when you divide any two numbers, even if they are integers, that result in a whole number, and you will always get a float in mathematically, right? So let's do this. For example, 4 here, 2, and we got 2.0 here. So if you mix an integer and float in any other operations, you will get a float as well. Like, for example, 1 plus 2.0, and we got 3.0. Let's actually use 2 multiplied by 9.0. We got 18.0. And if we this same applies for the multiplication here, exponential exponents. So 3 exponent 2.0, we are seeing here 9.0. So Python defaults to a float in any operation that uses a float. So even if the output is a whole number.